Everything is becoming application centric, and it's not surprising at all. Why? Because day by day number of application, mobile application, web application increasing, and the businesses are dependent on application, be it any sector, pharmaceutical, finance, of course, and power, any sort of enterprise, any small or a medium or large businesses, they are running on data. The data is the key at the moment. Faster the data available, accurate would it be. So it's all about information sharing, it's all about running the businesses, which is dependent or getting dependent on network data, connectivity through the internet. But what is the underlying infrastructure that is being used to deliver the information from one source to the destination, or between two sources? In a layman term, if I talk about, I have so far talked about cloud computing, how enterprises are opting for cloud computing. It is just for an ease of management, and in a moment, like there are certain things, certain services like EC2 called elastic compute cloud virtual instances. They are available as as an operating system in multiple flavor, Windows, Linux, and Mac as well. So that aspect I already discussed, why companies are opting, why businesses are opting for cloud infrastructure, for cloud services, whether it's uh, for development, for the development perspective, for developing an application, or just for utilizing an application, Office 365, SaaS, software as a service. They all are doing it. So lots of things are happening in terms of underlying things, that things which are not visible to end user, things which are not visible to the people sitting at the higher end. We are the people, the administrator, the network consultant, the lead consultant are responsible to ensure that end users have no difficulty while accessing these applications. When I say accessing these applications, while accessing to our data, which is crucial to run a business. It could be any sort of transaction, any sort of data. So how we are ensuring this reliability, availability, there's several things that we are doing. And it's not that all of a sudden over a night we started doing it. Nothing happened over a night. When the Paris was not built over a night, so definitely the network infrastructure was not built over a night. There were certain things started happening in 2012 when AT&T and other groups started thinking about doing some centralization of routing, doing we have to do lots of we had to do lots of policy based routing in terms of traffic engineering and all that stuff. That was also there with MPLS. MPLS played an important role, a what tremendous role in terms of providing the SLA. When I say SLA, this is called service level agreement, and still we can't get rid of MPLS. The sort of SLA MPLS is giving, still you cannot achieve with two multiple internet links. But yes, this is also true that we have wider pipes available. When I say wider pipe, we have more bandwidth available. So when we say wider pipe, more bandwidth, we are talking about a bigger, more lanes for running the traffic between two application, between client and the server. These are very small terms which I'm using, but definitely in terms of technicality, I will not be only talking, I will be showing you practically how things are done when it comes to build an application from the scratch, from choosing an operating, not from choosing the operating system, from choosing the private network VPC that cloud that Amazon has, or you know the Azure has a network connectivity, uh, direct internet connectivity, express and all that stuff. We'll be talking, and we'll also be talking about from the on-premises hub and spoke perspective, how you build an application, what is the basic requirement to build an application, the coding and all that will come into the picture later. But first, today I want to focus upon the SD-WAN part. Why so much talk is going on SD-WAN, and majority of the enterprises, almost it started in 2016. In the initial version of SD-WAN came in when Cisco long acquired a Viptela acquisition happened, and even the Riverbed launched its Steel Connect, but not able to sustain its, uh, the market. There were certain reasons that will also be discussed here in other videos. What was the main reason why Riverbed was left out or thrown out of the business? Why Viptela and VMware Velo Cloud got so much, uh, uh, you know, adoption in the market by enterprises? Because Cisco has a monopoly in terms of networking, routing, switching. No wonder nobody can defeat Cisco. So several, but there are other factors also to be checked. But that is a part of marketing. I don't want to get into it right now. So SD-WAN, this is a software-defined WAN. What comes to your mind when you think about software-defined WAN? You know, what used to happen? The uh, Okay, let's say if you want to transfer a file from one location to other location, you are a client and you have to fetch some information from the server. You use a certain transport. I'm not talking about the LAN. Once the packet throws out of the LAN switch, it goes to the router. From the router, which path it takes? It definitely takes the MPLS at this moment when you do not have other links like internet and broadband and all that. So in that, you know traversing data from one source to the destination, what all things come into the picture? What when you talk about MPLS, it's a kind of roadmap that you have through certain routers. The MPBGP and all that stuff that used to be a kind of havoc earlier. It's a cloud of MPLS. When we say cloud, it's a bunch of networking routing devices, domains connected together. So what was happening earlier, there were control plane. Actually, all these routers have control plane, management plane, and data plane. So what does management plane? It's very much understood from the name itself. The management, SSH, telnet, or through GUI, you access a device. Then comes to the control plane. What control plane has is the information of the path, how to deliver the packet from one source to the destination. The data is actual the packet, the data plane. So earlier all these things used to reside in one chassis. If you talk about 4500 switches or Catalyst 6500 switches, both are cat switches, and even the Nexus switches used to have all three plane, management, data, control plane, into same chassis. Soup model, the line card, all these stuff are very uh, they were very popular earlier when you used to have a hub and spoke topology and the data center. Nexus was a king in the data center. Even the Catalyst switches were king in the data center. Nowadays, even they are end of support, end of life. Nobody's thinking about these big chassis. Where I worked in the data center, used to take out the line card. I remember those days, how exciting it was. That's where when I started working. I remember in HCL setting up a server room for a client where we configured these switches, the stack switches and all that. We used to, these are very heavy hardwares. So, but yes, that was also fun, and today is also fun because everything is becoming software based. Click on your web. So the separation of data plane, control plane, management plane made it possible to make things easy from the customer perspective. It has become very easy to deploy, to terminate the WAN link and to on a zero touch and by just serial number and but some sort of information, system ID and all that, it is it will be live in a moment. So that is called, it's a zero touch provisioning. That is the fundamental marketing term came into existence with along with SD-WAN. But SD-WAN is something not new, as I told earlier. There were so many things Cisco tried earlier through IWAN, Meraki, and ACI. They were trying to do so many experiments through the centralization. The overall goal is to ease the management and do it through the central device. Here, the central device is the vManage, the control NMS, which does not only have capability of managing your edge devices, and the controller also have the capacity to give you the complete view of your network through the analytics. There is a granular reporting available. Even Cisco is giving the modules of security devices, the zone-based firewall. So in one box, you're getting everything. So that is the advantage of SD-WAN. That is one part. Centralized management, ease of control, ease of deployment, and other than these things, the cost reduction is also there. Some sort of uh, cost is also getting reduced, and V edges are located on your edge locations, like your on-premises control plane can be into the cloud, and the vSmart as well. So but all these things, are were possible earlier. They were trying hard, but it was not in that format, in that flavor that it can be implemented and given to the uh, produced into the market as a product. Now it is available as a product. Several companies, several organization vendors are in the market, running where Cisco and Vela Cloud are leading at the moment. Citrix has its own product. There are several vendors, but I'll be focusing only on Cisco because Cisco has a tremendous documentation. In terms of documentation, there is no match or catch with Cisco. Whether it's Thousand Eye, we have all the information available openly. So, what are the components available in SD-WAN? You have management plane vManage, and you have a control plane vSmart controllers. There could be two controllers and three controllers depending upon your requirement. And there is something very important, vBond orchestrator, which plays an important role in terms of providing authentication, providing the public IP, or ensuring that vManage and vSmart controller gets connected together. So connectivity assurance is there through the vBond orchestrator. So four basic component: vBond orchestrator, vManage, vSmart controller, and the vEdge devices. So that's one thing. Another thing is this uh, traffic flow. It's secure. Why it's secure? Because they're using a new concept of DTLS tunnel, and IPsec is given between the communication happens or between V edges to vSmart, or vSmart to your vBond. The all DTLS tunnels are available. Data sport, data layer transport security is there. So when they talk about security, definitely the digital certificate which needs to be signed, cryptography comes into the picture, and IPsec, you already know the IKE phase one and all that stuff that I'll be discussing when showing you the lab. And so we have discussed about this thing. So it's an application aware routing that we are doing through the SD-WAN. Transport independent. You have multiple transport. MPLS is not going anywhere. You have MPLS for SLA. You have multiple internet links for more bandwidth. The bigger the pipe, the easier the transport, the traffic flow, the centralized management already talked about. Separate data plane, control plane. It's a complete internet fabric. When I'll be showing you the diagram, you'll get more clarity on it. So what is next in here? Reducing the cost with the transport independence. I don't think we are actually reducing the cost. Yes, to certain extent, MPLS was costly, with multiple, if you one MPLS link and two internet links, so they are equivalent. But again, the reliability MPLS still needs to be considered very well when you are choosing, opting, resizing your uh, business. So that is another thing. When you do a resizing, how do you calculate how much bandwidth you require when you are getting rid of MPLS? I won't suggest you get rid of MPLS straight away. First, go with MPLS plus internet link in parallel. Design the baseline, understand, make sure that you have dedicated link for certain applications. Other applications you use a different link. So definitely, if you're going to the cloud, you will be using internet direct access, and for your in-house application you will be using the MPLS. So that is fine. Even the management traffic can go through the MPLS, so that is an advantage of this SD-WAN. Independent transport, you don't have to be dependent on whether your traffic is based upon the routing going through MPLS. So it's all applications, and other than application there are certain parameters that you need to set up: jitter, latency, and response time. So based on this, if something goes wrong, automatic failover happens from one provider to another provider. By the time you fix it, you do not have failure or any degraded to the performance. So that is what availability and reliability, that's what I talk about. Authenticity is already there, security is already there. Zero touch provisioning, I've already talked. I'll show you how it is done, why it is called zero touch provisioning, because something is embedded into the chassis itself through the serial number, your organization, system ID, and all these things are available. Yes, the dashboard, the vManage dashboard is quite user friendly. You have each and every information. You do software upgrade, creation of template. Yes, that is very important. That happens through the vManage. You create a template of policies, what sort of QoS control policy, what sort of policy you need to push. So these templates are there, modified, and on CLI things doesn't happen. You have to do it through vManage. That is very important. So that's the seamless extension of the WAN. Detailed reporting of application, I've already talked about application aware routing, secure data and control plane operation, simplicity at enterprise level, which enable end-to-end policy from the end user. Yes, delivering fast cloud access by enabling direct. I've already talked about this. Now in the next video, I'll be showing you the diagram and the EVNG, which I've created a lab, and how the traffic flows, what all things which I've just talked about, vSmart, vBond, and vEdges, overall connectivity, I'll be showing in next video. So thanks, stay connected, stay tuned, and I'll see you soon. Thank you so much. Take care. Bye.